Who among you have heard of Angry Birds and see how the birds travel in a parabolic or curved path? I love that as a kid, just saying. Hello there, it's Mark here, yeah, physics boy. Yes, we'll be talking about physics, specifically about projectile motion. Great application of mathematics, by the way. But before we delve to the mathematical side of it, let's first define key terms. Projectile, in simple terms, is the object involved. Say if you're shooting a ball, the ball is the projectile. Easy peasy, right? You may have also heard about free fall and throwing a thing vertically upward. Projectile motion, well, works like that. Except that an object is thrown at or released at an angle and not just vertically upright. Hence making the projectile consume horizontal distance also, and move in a curved path which is influenced by gravity. Which leads me to another way of thinking of it, that it is the combination of horizontal and vertical motions working together. What if you throw a thing horizontally? Will it work? It's a yes, because the projectile will eventually go down because of gravity. Trajectory is a path traveled by the projectile, which is a parabola or a curve in general. Mathematically speaking, we shall refer to the parabola as something symmetrical in nature, meaning when you cut it vertically into two, the two parts should look like they're mirroring each other. Because parabolas are symmetrical, what's on one side should also be on the other side in terms of the speed or magnitude or the number. However, we also consider the direction and velocity. So say for example, you're given a vertical velocity on the trajectory's first half. Say for example, 10 meters per second. Its reflection on the second half simply differs in the sign because it's already going down, which means on the second half, it's already negative 10 meters per second. It can also be only a part of it depending on the scenario. It can be both cases combined. For this clip, we shall neglect air resistance which may alter the trajectory. Given the different trajectories with the same initial velocity, then the projected angle, time in air, and the peak height are directly proportional, which means that if one of them increases, the other two variables should increase also. It is at the 45-degree angle that yields the greatest horizontal distance, or simply the range. The closer the angle is to 0 or to 90, then the shorter the range will be. Two angles that are complementary, or simply two angles that add up to 90, yields the same equal range. Because the trajectory is curved or basically angled, we need to extract their horizontal and vertical components simply by using this formula. To determine the resultant or the vector that shows the two components working hand in hand, we will use the following. All these formulas are based on Pythagorean theorem and basic trigonometry. You may have seen these formulas in one-dimensional kinematics, and we're still using these, except that we will add another subscript, either x or y, in all variables except time, to differentiate the horizontal and vertical components. For acceleration in horizontal direction, or a sub x, it is always 0 meters per second squared, or 0, because there is no horizontal force that is acting while the projectile is in the air, making the horizontal velocities the same all throughout, which is in line with Newton's first law of motion. Every object remains at rest or in a uniform speed unless acted upon by a force which will change the object's speed. For a sub y, it is always negative 9.81 meters per second squared. Yes, it's always negative because it's the gravitational force that is pulling an object downwards. Take a look at the figure. As the projectile goes up, the green arrow gets shorter, and it slows down until it reaches the peak height, or the vertex. It momentarily stops there. Then it goes down, the green arrow gets longer, and it drops faster. Therefore, at the peak height, the velocity is at its minimum, and its y component is 0 meters per second. There are a lot of applications of projectile motion. Maybe you don't see it, but when you pass something to another person, when you guys are far from each other, there's a curved path that an object passes through. That's one application. Another one is maybe you guys love shooting your trash in trash bin, which by the way is not a good habit. A lot of sports exhibit this also, because you need to have an appropriate angle to reach a goal. Let's look closely at the badminton though, which is by the way my primary sport. I've got some tips for you when solving projectile motion problems. I usually visualize the situation and break it down into smaller scenes, and that actually helps a lot. I also plot the position's coordinates, especially the y position, so I would know the initial and final position later, which you will be shown later. I'll usually let the ground level y equals 0 to have a reference. Of course, I list down all givens and unknowns per scene, so I could get the formula that yields to only one unknown variable. Then, I simply get the formula and use the math. Do the math. Now, let's go to the word problem. So just simply pause the time if you need more time to read. As you can see from the illustration, I broke down the entire trajectory into two parts, the symmetrical parabola in yellow and the small curve in blue. I also used y equals 0 to label the ground. Hence, y equals 1.55 means that it's 1.55 meters above the ground. Here are the following given variables based on the problem and our mini discussion earlier. As you can see, I already extracted the components of the initial velocity. But let's focus first on the yellow part. Recall what I told you earlier about symmetry, and by applying that, the velocity of the y component at the end of this parabola has the opposite sign as the one at the start of this parabola, but with the same number essentially. That is where I got Vy equals negative 6.19 meters per second at that point. Focusing on the first half though, I calculated the time to reach the peak height, and from the given, I decided to use that formula and plug in the values, with resulting t equals 0.63 seconds. The total time to reach the full parabola is simply twice of it, which is 1.26 seconds. But take note that it's not the final total time that the shuttlecock is in the air, as there is still the blue part, which is a continuation. And in that scene, negative 6.19 meters per second is already the vertical initial velocity, or v sub 0y. From the given, I decided to use that formula and plug in the values again, which led me to the quadratic equation shown. Because of that, I decided to use a quadratic formula to get t, plugging in the correct values. And here comes the importance of rearranging the equation like ax squared plus bx plus c. By using this, I got two values of t, but we can only get the positive one, because negative time value means it occurred before the situation. Hence, for this, t equals 0.21 seconds. Adding the two, we have the total time as 1.47 seconds. Now let's get the velocity just before it hits the ground, and again, we will focus on the blue part. Now that I have the time for the shuttlecock to complete this blue part, I decided to use this formula as shown and plug in the values to find Vy, which is the y component velocity at that endpoint. Hence, we get Vy equals negative 8.25 meters per second. Recall that Vx remains constant all throughout, so Vx at that point is also 19.52 meters per second. From the figure, we basically use Pythagorean theorem to get the resultant, and hence I get V equals 21.19 meters per second. We also get the angle because it gives us the direction and it's needed in velocity. By using SOHCAHTOA or basic trigonometry, we get theta equals negative 22.91 degrees. Hence, we have the velocity 21.19 meters per second. And since theta is negative, we can say that the angle is 22.91 degrees below the horizontal.
And that's it for our video, and I hope that by watching this lesson lecture, you have learned something new today and you may learn to appreciate physics in general better in your everyday life. This is Mark Rodriguez, your boy, and like and subscribe. See you soon.